visualization in exercise, and we did talk about the general kind of question that you would like to know. I'm not going to go through that question again. And very important thing, actually this table, this slide is very important before we talk about exercise and visualization, and this will, if you can remember all this information, that will help you to understand better. So the metabolic characteristic of a major skeletal muscle fibers, right? So we actually have a different type of fibers in our muscle, and each type of fibers has a different metabolic characteristic. Means that they have different content of a mitochondria, the different capability of oxidation, and or different amount of stored energy, like glycogen versus triglyceride, everything. So probably you will be kind of scared. Okay, this kind of information, how can I memorize it, right? So I tell you a trick, a tip. Is I think it's very useful. Mitochondrial content. Try to remember mitochondrial content in each fiber type of fibers, right? And then the rest of the information should be very easy to memorize, right, or understand, memorize. We actually have 3 different type of fibers. So type 1, red fibers, and type 2A red fibers, and type 2X fibers, right? 3 different type of fibers. And you wanted to remember type 1 red and type 2X. These 2 type of fibers are very different, has like opposite metabolic characteristics. And the middle one, type 2X, is kind of intermediate. The characteristics have both fibers of characteristics. So type 1, so if you look at the mitochondrial density first, so type 1X red fibers is a slow twitch and slow oxidative and fatigue-resistant fibers. And this type of 1 red fibers contain a very high amount of mitochondria, right? So that's why the muscle fiber looks red, because they have a lot of mitochondria, right, in the muscle cells, in fibers. So type 1 red fibers contain a very high numbers of a mitochondria, and type 2X basically is white fibers, right? And it can twist very fast, but has a very high glycolytic capacity. So type 2X fiber basically fibers have a low mitochondrial content. Right? Does that make sense? So you look like white, and more white compared to the type 1 red fibers. And type 2A fibers in type intermediate, right? They have an intermediate amount of mitochondria. So once you remember this, and it will be very easy to remember the other things. So for example, let me just go through from the top to bottom, right? So in terms of the composition, the type 1 red fibers usually account for 50% of the muscle fiber. So our muscle, 50% of muscle fibers are type 1 red fibers, right? And 40% is type 2A, and only 10% of muscle fiber in our skeletal muscle is the type 2X fibers. And they have a different contraction kind of activities. So type 2, type 1 red and type red fibers kind of slow twitch, right? And 2X is faster twitch, so very fast, right? And resistant to fatigue. The type 1A, type 1 red fibers is very high. You have very high resistance to fatigue. That means the type 1A fibers are not easy to get fatigue, right? And type 2 X fibers, they're very easy to get fatigue. So the reason we're going to talk about later, because of the type 2X fibers has a lower mitochondrial content, right? So this type of fibers are not able to oxidize fatty acids and also glucose. So glucose only goes partial oxidation, right? To produce a lot of lactate acid. So lactic acid is the concentration high. The accumulation of lactic acid is the cause of the fatigue, right? So that is, so you can connect it, right? So because, again, type 2X fibers have a lower oxidative capacity because of a lower mitochondrial content. So an oxidize energy, particularly glucose, and through the partial oxidation, I generate a lot of lactate. So that is something related to the easy to get fatigued, right? And in terms of type of oxidative metabolism, aerobic versus anaerobic metabolism activities, the type 1 red fibers, because of a high mitochondrial content, right? So you will expect this type of muscle fibers will usually do the aerobic metabolism, right? And type 2X usually do the anaerobic metabolism. And then the for ATP production, right? And then the oxidative capacity will be very easy to understand, right? Because of a high mitochondrial content. So in that type 1 fibers, so type 1 fibers should have a higher oxidative capacity, right? And 2X have a lower oxidative capacity. And glycolic capacity is just kind of opposite, right? Because, type 1 fibers, because they have a high mitochondrial content, so you usually complete oxidize fat and carbohydrate, so you should have a lower glycolytic capacity. And 2X fibers basically have a higher glycolytic capacity, again, because of lower mitochondria, right? And also the creatine phosphate content. Creatine phosphate is only used by a type 2X fibers, because type 2X fibers cannot utilize fatty acids for energy, again, due to the lower mitochondrial capacity, right? So the creatine phosphate is a very important energy sources for type 2X fibers, but we're going to talk about later, right, during the anaerobic exercise. And the glycogen content, so I just ask you a question. So glycogen content, what do you expect? Which type of fibers should have a higher glycogen content? Type 2X versus type 1? Yes, 2X, right? So 2X, because they need a carbohydrate for energy, so the type 2X have a much higher glycogen content compared to type 1 fibers. And what about TG triglyceride content? I mentioned earlier, right, the muscle cell also contain some or store some triglyceride for energy during exercise. So type 1 versus type 2X, which type of fibers should have a higher triglyceride content? Type 1, yes, because type 1 have higher oxidative capacity, so you're able to use fat as energy, but type 2 not able to, right, use fat. So it's no use for type 2 to store triglyceride. So that's why type 1 fibers should have a higher TG content. Okay, any question? So once you remember all these characteristics of metabolism in each type of fibers, and it will be very easy to understand, right? The okay. Oh, actually, I have information here. Do you guys have all this information, right? No. Okay, slide. Okay. Now we'll just go through again the different type of type fibers. Type 1, and again, is a slow twitch fibers and have a higher mitochondrial content, so have a higher oxidative capacity, and usually do the aerobic metabolism, right? Particularly for fat oxidation, but can also do the glucose oxidation. Like here, I'm mentioning the glucose complete oxidized, right, through the TC cycle. And this type of fiber is suitable for performing the endurance exercise, for example, marathon. So marathon type of exercise usually utilize this type 1 fibers, right, for doing during the exercise. How is the glucose metabolized in type 1 fibers? I mean, the metabolic pathway, glycolysis, and complete oxidation. How is glucose metabolized in type 1 fibers? Complete oxidation or partial oxidation? Should complete oxidize, right? Because again, have a high oxidative capacity, higher mitochondrial content. Now type 2A. Type 2A, have both type 1 and type 2, type 2X characteristics because it contains the intermediate content of a mitochondria. So type 2A fiber is also the fast twitch, but it can do the moderate oxidative activities, right? So the type 2A fibers are able to do both aerobic and anaerobic metabolism, right? So that means the glucose or glucose, it can be oxidized in the type 2A fibers through glycolysis as well as a complete oxidation, further oxidized through the TC cycles, right? And this type of fibers usually used to perform the mid-distance running or swimming, this type of exercise, right? Usually use type 2A fibers. And 2X is fast twitch fibers, and because of a lower mitochondrial content, so it have a lower oxidative capacity, but very high glycolytic capacity because of a high content of glycogen, right, stored in the type 2X fibers. And again, because of a lower mitochondrial content, so the 2X fibers usually do the anaerobic metabolism, right? So glucose is oxidize only partially, right, and generating lactate. And again, because of the glucose, most of glucose, the partially oxidized, right, to generate lactate. So this 2X fibers usually related to the fatigue. You are very easy to get fatigue. And in the long-term exercise, and at the 60 to 75% of oxygen, maximum oxygen capacity, which I'm going to talk about later, right? So maximum oxygen capacity usually is used to measure the exercise intensity, right? So again, during the long-term exercise, for example, like a marathon type of exercise, the type 1 fibers and type 2 fibers are recruited during the early stage of exercise. So again, the early stage of exercise, like a marathon, usually you muscle will get a lot of type 1 and type 2 A fibers for exercise. But when exercise goes longer, then type 2 X fibers is also recruited to try to remain the the same intensity of exercise, right? Yeah, I think we talked about it already. So type 2 fibers, yeah, right? Because oxidized glucose and generally a lot of lactate, so very easy to get fatigue or associated with fatigue. Now let's talk about type of exercise. So in terms of metabolism, 2 different type of exercise, right? The aerobic exercise and anaerobic exercise. So aerobic exercise basically is exercise you going to have like modulate intensity and undergo for a relatively long duration, right? And an important thing for aerobic exercise is body need to utilize oxygen, right, for this type of exercise for energy ATP production. So marathon is an example of a aerobic exercise, right? So again, aerobic exercise need oxygen and involved in the mitochondrial oxidation, right? So this, and example is a marathon, is a long duration, for a long duration. And anaerobic exercise is a short-term exercise but utilize very high, energy, right? Require, high energy for exercise. So example for anaerobic exercise is the sprinting. 100 meters sprinting, right? This type of exercise only takes like 10 seconds, right, to finish. So it's very quick, short-term exercise. Why it is aerobic, 100 meter sprinting type of exercise? Why it is an anaerobic exercise? We know the aerobic exercise requires oxygen, right, for oxidize glucose and fatty acids for energy. And anaerobic exercise is very short period of time, only 10 seconds. So the oxygen will not be quickly enough to get muscle, right, for oxidation. So this type of exercise, we only utilize the in the stored energy in the skeletal muscle for ATP production, and will not be able to involve the oxygen and oxidative metabolism in a mitochondria. Okay, now let's talk about exercise intensity. So how to define exercise intensity? So exercise intensity usually is determined by muscle contraction cycles per unit of time, like per hour or per minutes or whatever, right? So the higher the exercise intensity, the more contraction cycles are needed, right, for per unit of time. So more ATP actually needed when you go more contraction cycles, right? You need more ATPs need to be synthesized within the certain unit of time. So that means more energy fuels are needed, right, to oxidize to produce ATPs, right? So exercise intensity is related to energy utilization, energy oxidation, right? So ATP production. So high intensity exercise requires more ATPs, requires more energy fuels utilization. And usually, in general, the rate of ATP synthesis and the fuel utilization, oxidation in muscle is increased during exercise. If you compare the beginning to the middle stage and later stage of exercise, here I'm talking about aerobic exercise like marathon, right? So the ATP production or energy oxidation, fat oxidation or energy oxidation, we'll say, will be gradually increased, right, from the beginning to the later stage of exercise. So how are we going to measure the exercise intensity? Again, I mentioned, right, exercise intensity related to the ATP production and oxygen consumption, right? You oxidize energy fuels and you need oxygen, right? So we usually people use the so-called maximum oxygen consumption as a measurement of exercise intensity. So usually a person's, individual's maximum aerobic or oxygen capacity, defined as 100%, right? But I want to remind you that each individual, although they define 100%, but each individual's oxygen consumption, maximum oxygen consumption is different, right? But again, 100% is defined. The maximum oxygen capacity defined as 100%, right? And then you measure the oxygen that can be used, right, by the body during the exercise per time of unit. So how much oxygen can be used during exercise, right, per unit of time, like for example per minute or per hour or whatever they used. So then you can determine each individual maximum oxygen capacity, right? And here's something that you need to remember is the percentage, how we define the low intensity, moderate intensity, high intensity exercise. We use the percentage of a maximum oxygen capacity as an indicator, right, of the different levels of intensity. For example, low intensity exercise, usually like a fast walk, type of activities considered is the low intensity, but usually you only use 25% of individual maximum oxygen capacity, right? Only use 25 of maximum capacity. And for the moderate intensity, like a faster jog, you use actually 60% of the your maximum oxygen capacity. And high intensity, like 2-hour marathon exercise, that you usually use 80% of the maximum oxygen capacity. So again, 25% defined as a low intensity, and 60% moderate intensity, 80% high intensity, right? Is that clear? Any question about this? Okay. And oxygen is usually linearly related to the energy expenditure. That means if we use more oxygen, means we oxidize more energy fuels, right? Or more fatty acids or more glucose. So that the energy expenditure is related to energy expenditure, and greater consumption of oxygen is also related to greater the intensity exercise, right? Like last slide I was showing, right? Low intensity 25% and moderate 60%, high intensity 80%. And also important thing is the training can increase oxygen consumption, right? It can increase the maximum oxidative capacity. We have some information about this later. So about like a 10 to 20%, right, increase. And maximum oxygen capacity can be increased. Oh, actually, it does. 15 to 20%, right, with the training. So after training, so your maximum capacity can be increased by 15 to 20%, right? So so definitely, you have a different performance if you compare the untrained versus trained, right? The athlete or whatever. So fluid utilization in skeletal muscle during the resting state that we talked about before, right? The fasting fat condition. We usually in the fat condition muscle usually use more glucose, right? And fasting condition utilizes more fatty acids for energy. And other thing important is that the muscle cells usually use a mixture of carbohydrate and fatty acids for energy, right? Be able to use both carbohydrate and fatty acids. And during the resting condition, the blood-borne fuels are the most important energy fuels. Blood-borne fuels mean that the glucose or fatty acids basically that muscle get is from the circulating, right? For example, during the fat condition, we absorbed a lot of fatty acids, glucose from the diet, right? So we have a high levels of glucose in the circulation. So our muscle usually pick up the glucose from the circulation, right? And during the fasting, we also have a high. We muscle get glucose also from the circulation, but this glucose usually from the liver, right? So liver glycogen breakdown and gluconeogenesis, and most importantly during fasting, the fat tissue release fatty acids, right? So muscle also pick up the the fatty acids from the circulation, which initially from the adipose tissue. An important thing that I want to mention that during the resting condition, the so-called intramuscular fields, right? Intramuscular fields are not an important energy field for muscle use during the resting condition. So again, the main point here is that during the resting condition, muscle you usually do not utilize intramuscular fuels, right? We know muscle can store glycogen, right, and also some triglyceride. But stored glycogen and stored triglyceride are not utilized by the muscle during resting condition, right? But during the exercise, so this intramuscular energy fuels become very important sources, right, for muscle use during the exercise. So here's the list of the energy fuels that muscle can use during exercise. So for example, carbohydrate, blood, glucose as one of the carbohydrate source, right, for the muscle use. And liver glycogen also break down glycogen, release glucose into circulation, so muscle can also pick glucose from circulation and use for energy. And most importantly, muscle glycogen, right, as the very, very important energy carbohydrate sources, right, for muscle during exercise. And fat is also important. And free fatty acids, so muscle can utilize free fatty acids from the circulation, right, which initially from the adipose tissue during exercise, and also triglyceride, right, that being delivered from the liver, in the VLDL, right, so muscle LPL can hydrolyze triglyceride in VLDL, and you pick up fatty acids for utilize as energy. But again, important intracellular, intramuscular triglyceride store as also the important sources of fatty acids, right, for energy use during exercise. And lastly, muscle creatine phosphate is important energy fuel only for type 2X fibers, right? Because X2 fibers do not oxidize fatty acids, right? Not able to oxidize fatty acids for energy. So creatine phosphate plus the glycogen, muscle glycogen, right, are the most important sources for type 2 fibers. Okay, any questions? Right? Let me see. So energy utilization is also increased during exercise, right? Because of the availability of carbohydrate and fatty acids is increased, and also the ability of muscle to oxidize both carbohydrate fatty acids also increase, right? Both availability increase, and also the oxidation capacities increase during exercise. This is just a common concept that you probably wanted to know. Okay, so energy costs the of a working muscle or exercise muscle. So muscle contraction, like shortening or movement, usually require energy, right, of course, from the hydrolysis of ATP, right, and by ATPs, a different ATPase, the enzyme. And our body usually only use about half of a muscle for running a marathon, right? Not like the whole muscle body muscle are used for running marathon. Only half of our muscle, right? That involve the marathon exercise, and most of ATP required for a marathon that is produced by aerobic oxidation, right? For carbohydrate, both carbohydrate and fat. And most of ATP needed for 100-meter sprinting is actually anaerobically metabolized, right? From the anaerobic metabolism of glucose, and also creating phosphate glycogen, right? So again, different type of exercise, aerobic versus anaerobic exercise, it utilize different sources of energy, and also energy metabolism is also differently. So two things are different, right? Aerobic exercise utilize both carbohydrate and fatty acids for energy, and this carbohydrate, glucose and fatty acids can be completely oxidized, right? And for anaerobic exercise, you're only able to use creatine phosphate and glycogen, like muscle glycogen, as the energy sources. But the glucose is only partially oxidized, right? So try to remember, different sources of energy, and the way of the glucose metabolite is also differently, different type of exercise. Here just give you some idea how ATP is used for energy. So both glucose and fatty acids oxidize, produce ATPs, right? And three different type of ATPase enzymes can hydrolyze ATP and release energy, and this energy be used for a variety of activities in skeletal muscle, right, including muscle fiber contraction, shortening movement, and also polarization and depolarization of muscle cell membranes, right, in response to like nerve signals or something like this, and also calcium release, right, it's in the muscle fibers is very important in order for the muscle contraction. Now here I just wanted to tell you a little bit more information about the energy sources of for the aerobic exercise. Again, different type of exercise, different, right? So let's talk about aerobic exercise. So during aerobic exercise, muscle able to use glucose and fatty acids, right? And glucose can be from blood glucose, which can be from the diet, right? And also from liver glycogen breakdown. And the other important source is muscle glycogen, right, breakdown. And for fatty acids, it also can include the circulating fatty acids, initially from either from diet or the adipose tissue released, right? And triglyceride in the VLDL, and also intramuscular triglyceride. So we have two actually diagram and show you better idea how sources of glucose, how they contribute to the energy, right, production in the muscle during exercise. So here is the glucose. So you highlight three different sources of glucose, right, for muscle use, energy. First is from the diet, so dietary carbohydrate. It contribute like 60 gram, right, per hour, and the second sources of glucose is from the glycogen, liver glycogen breakdown, right? And the third, which is most important sources of glucose, is the muscle glycogen. So again, I want to mention the muscle glycogen is a major sources of glucose for ATP production during exercise in the muscle, right? If you compare the amount of, how much the glucose that contribute from muscle, diet, and the liver, you can see that muscle usually have 350 to 800 gram of glycogen stored, right? And diet, you only get 60 gram, and the liver, 70 to 80 gram. So the amount, actually, the muscle glycogen is most important, right? The contributor to glucose utilization in muscle during exercise. So I listed the two questions that I think it's important. I hope you can understand, right, and remember. So first is where does glucose used in muscle come from during aerobic exercise? Three sources, and the most important source is muscle glycogen, right? And the second question, how is glucose metabolized during aerobic exercise in the muscle? So two things. One is in terms of fibers, the three type of fibers, right? Type 1, 2A, and 2X are able to utilize glucose for energy, right? But they metabolize glucose differently. Type 1 and type 2A fibers, because they have a relatively high mitochondrial content, right? So these two type of fibers be able to metabolize glucose aerobically. That means they be able to oxidize glucose and produce less lactate, right? But type 2X fibers, again, because of a lower mitochondrial content, so most of the glucose is metabolized anaerobically and produce a lot of lactate in the type 2X fibers, right? That makes sense? Okay, any questions? Okay. Should we take a break?